Ever pondered what makes the apple fall from the tree, or how a car speeds up on the highway? This inquiry isn't just simple curiosity, but a dive into the fundamental dynamics of our physical universe. This isn't just about asking why things happen. It's about understanding the intricate relations, objects, energies, and forces that govern the everyday phenomena we often take for granted. These phenomena aren't merely acts of random chance. Far from it. They are distinctly governed by two core concepts in physics: force and acceleration. These invisible yet inescapable phenomena are the puppeteers behind the movements and changes we see around us. They structure our world and our understanding of ways we may overlook, but are undeniably crucial to virtually every aspect of our existence. Force, as defined by Sir Isaac Newton's groundbreaking laws of motion, is an interaction that, when unopposed, changes the motion of an object. It's like a subtle yet powerful push or a pull. This push or pull is a silent orchestrator, invisible to the naked eye yet omnipresent, that can make objects move, halt, or alter their direction. Imagine for a moment pushing a shopping cart in a supermarket. When you apply a force, even a mild one, to the cart, it begins to roll, it starts to move. The very act of you pushing is an application of force, a tangible manifestation of Newton's laws in our everyday life. And you'll notice a distinct pattern. The harder you push, the faster the cart moves. As you exert more force, the cart accelerates more. It's fascinating to see such a simple and mundane act as a clear example of the principles that rule the cosmos. But then what happens when you remove that push? When you cease pushing the cart, what happens? As you would expect, the cart doesn't continue moving at the same speed. It gradually slows down, its speed diminishing steadily. It rolls less and less until eventually it comes to a complete halt. Now, why does this happen? Why doesn't the cart just keep forever? It's due to another unseen yet equally important force at play: friction. Friction is the force that resists the motion of one surface over another. It's a ubiquitous force, a universal constant that is always there. It's a silent adversary, constantly working against our everyday movements and actions. It's why a rolling ball slows down, why a sled grinds to a halt, why we can walk without slipping. Even though we may not always realize it, friction is there, a quiet reminder of the complexity and beauty of physics. It's the subtle dance between these forces that makes our world turn, and yet it is so seamlessly woven into the fabric of our lives, we often forget its existence. But just as the sun continues to rise, so does the apple continue to fall. Friction continues to resist, and the beautiful symphony of physics continues to play. It's a ubiquitous force that constantly works against our everyday movements, even though we may not always realize it. Now, let's delve into the fascinating world of acceleration. To understand acceleration, it's crucial to note that it is defined as the rate of change of the velocity of an object with respect to time. This essentially means that acceleration encompasses not just the process of speeding up, but also covers slowing down and even changing direction. In essence, it's a measure of how an object's speed or direction changes over time. Let's take a common example, such as a car accelerating from a standstill to 60 miles per hour. This scenario perfectly the concept of positive acceleration, where the speed of the car increases over a certain duration. The car starts from zero, gradually picking up speed until it hits 60 miles per hour, showcasing a clear increase in velocity over time. But acceleration isn't just about speeding up. Consider a slowing train. This is an example of negative acceleration, commonly referred to as deceleration. The train's speed decreases over time, the velocity reducing until it eventually comes to a halt. Similarly, a turning bicycle is an example of acceleration concerning change in direction. As the bicycle changes its course, it accelerates, illustrating that acceleration isn't simply about straightforward speed change, but direction change too. Consider another scenario, throwing a ball straight up. It starts with a certain speed but slows down as it ascends, reaching its peak where it hangs for a moment. At this highest point, the ball is motionless for a split second before gravity takes over and it starts to speed up again as it falls back down. This change in speed, first decelerating, then accelerating, beautifully demonstrates acceleration in action. This change in speed, slowing down and then speeding up, is acceleration in action. To tie these two concepts together, Newton's second law of motion tells us that the force acting on an object is equal to the mass of that object multiplied by its acceleration. This principle lies at the epicenter of the captivating world of dynamics, the riveting study of how forces, in every sense of the term, influence and dictate the motion of objects. Now, to delve a little deeper into this fascinating realm, we must first comprehend the intricate relationship between force, mass, and acceleration. You see, the force we apply on an object significantly influences its acceleration. This correlation is quite simple and intuitive. The stronger or more intense the force applied, the greater the acceleration of the object. But this is not an isolated interaction. The mass of the object equally plays a pivotal role in determining the acceleration. The heavier or more massive the object, the lesser the acceleration for the same amount of force applied. Hence, force, mass, and acceleration are interlinked in a delicate yet powerful dance of physics, governed by Newton's astute second law. Now let us shed some light on these fundamental concepts which orchestrate the world around us. Force, in the simplest terms, is a push or a pull. It has the incredible power to alter an object's move. It can cause things to move, halt their progress, or change their direction entirely. It is an unseen player in every physical interaction, making its presence felt through its undeniable effects. Acceleration, on the other hand, is a slightly more complex concept. It is the rate at which an object alters its velocity. This includes speeding up, slowing down, and altering direction. It's the measure of how swiftly an object can adapt its motion in response to forces acting upon it. It's a testament to the object's agility in the face of physical interactions. Newton's second law of motion is the key that links these, declaring that the force acting on an object is equal to its mass multiplied by its acceleration. This law symbolizes the harmony of physics, binding together different aspects of motion into a cohesive whole. So the next time you watch an apple tumble from a tree or push a shopping cart in a grocery store, remember the invisible hands of force and acceleration at work. They may remain unseen, but their effects are as palpable and real as the world we inhabit.